Good day. For today's lesson, it is about relations and functions. Relations is a role that relates a values from a set of values called domain to a second set of values called trace, or it is a set of ordered pair. Ordered pair is the pair of elements that occur in a particular order and are enclosed in brackets, or any two numbers separated by a comma enclosed by a parenthesis. That is what we called ordered pair. It is a set of ordered pair. Now, then, the first element, which are 2, -1, 4, 9, and 0, are what we call the domain. The domain is the set of all x values in the relation. The same set of ordered pair, the second elements, which are 3, 5, 2, 9, and -6, are what we call the range. The range is the set of all y values in the relation. Okay. What makes a relation a function? So, a function is a process or a relation that associates each element of x of a set of x is the domain of the function to a single element y of another set y is the range of the function. Or in other words, in every x values must associated to only one y values. Okay, we have 4 ways to represent function. Number 1, table of values, ordered pair, mapping diagram, and graph. So let us first talk about table of values. So I have here 3 table of values. How do we know that this table of values represent a function? So this is how. First, you have to look at the values of x and the value of y. Then after that, look at the value of x if there are repetition of numbers. If none, then that is a function. If there is a repetition of x values, then that is not a function. For this number 1, our x values are 1, 3, 4, 5, and 6, associated to the value of y 0, 3, 5, 7, and 9, in which there is no repetition of the x values, meaning to say this is a function. For number 2, the value of x are 6, 6, 9, 11, 13. These are associated to the value of y 0, 3, 0, 7, and 9. So as you can see that there are numbers, or there is a number repeated in the x values. So I mean to say this is not a function. For number 3, we have the value of x 1, 3, 4, 5, and 6 associated to the y value 1, 5, 8, 12, and 15. It is a function. Another way of representation in function is ordered pair. Okay, the ordered pair is something like this. The set of ordered pair named F, the set F containing these elements, which are this one. So as you can see that the value of x, which are 1, 2, 3, and 4, are not repeated. So this is a function. For the G set, we have 1, 2, 3, 3. There are 2 numbers are repeated. So we can say this is not a function. For H We have 1, 3, 5, and so on and so forth. So this is a function because there is no repetition of the value of x. Okay, the next is mapping diagram. In mapping diagram, we have the set of domain is consisting the value of x and the set of the range containing the value of y's. Okay, how to determine that the diagram shown is a function or not? So we have to consider this condition. First is must use all the x values. You see, all the values of our domain are used in association with the values of y. Then second is the x value can only be assigned to one y value only. So I mean to say that each of this value is associated to only one value in the range. So as you can see, our 1 is for 6, 2 is to 2, 3 is to 4, 4 is to 8, and 5 is to 1. So all we can say that this is associated, the value of the domain or its value of our domain is associated to its value of our range. So we need to say this is a function. Okay, let's take this one example. Okay, as you can see, the first, this is our domain, this is our range, our input and our output. 9 is associated to 3 and negative 3. 4 is associated to 2 and negative 2, and 1 is associated to 1 and negative 1, and 0 is associated to 0. So this is not a function. Why? Because as you can see, 9 is associated to one or more values of y. This is what we call one-to-many correspondence. This is not a function. Then mapping diagram. See, next example for mapping diagram is this one. So let us inspect. A is associated to 8, B is associated to 5, C is for 8, D is to 10. For B, there is no question. B is associated to only one value of y, and for D is also associated to one value of y. But for A and C, they are associated to one value of y. So what can you say about this? Is it a function or not function? It is a function. It is a function. Why? Because this association is referring to many to one correspondence. Okay, the last one. Okay, as you can see, it is clearly the domain values is associated to only one value of y or our range. So it is clearly it is an example of a function, and this is referring to a one-to-one correspondence. If it is a one-to-one correspondence, then it is clearly a function example. Okay, the last representation of function is a graph. Okay, here is a graph. How do we know that this is a function or not? So in the determination whether a graph is a function or not, we need to use the vertical line test. A vertical line test is a visual way to determine if a curve is a graph or a function or not. If all the vertical lines intersect a curve at most once, then the curve represents a function. Okay, I have here a vertical line test. If I move it forward, let us see how many times the vertical test curve touches our graph. Okay, from there it is once. If I move forward, still touches 1. So this is a function. Next graph. If I move the vertical line test, there, it only touches once. If I move it forward, still it touches once. So this is an example of a function graph. Then the last one. If I move forward this vertical line test, it touches the curve twice. These points and this point. If I move it forward, still it touches 2 points of the curve, meaning to say this is not a function. So that's all. I hope you understand that how to identify whether a certain representation is a function or not from the table of values, ordered pair, graphing, and mapping diagram. So for now, I will say thank you for viewing my video, and I hope this would help you to understand what relation and function is all about. Thank you, good day, and God bless. Keep safe.